Hello, my name is Mahmoudi-Nejad. Welcome to our presentation titled Automated Personalized Exposure Therapy based on Physiological Measures using Experience-Driven Procedural Content Generation. Exposure therapy is known as the most effective psychological treatment to reduce fear and anxiety responses and decrease avoidance. In this therapy, a subject is gradually exposed to a feared situation or object in a safe environment, learning to become less sensitive over time. The problem with existing VR exposure therapy systems is that most of them use a generic VR environment, which means that they use fixed VR parameters regardless of subjects' characteristics and conditions. However, it is easier and cheaper to design these systems. They might cause disengagement, boredom, and cognitive overload in the subjects. The solution is using adaptive virtual reality exposure therapy, like the study by Bian et al. They developed a driving training system for individuals with autism spectrum disorder. It changes the difficulty of the levels, which means the obstacles and the speed of the vehicle, adaptively based on the participants' engagement level. Adaptive VRET comes into two main categories. Manual, which requires the therapist to modify the VR parameters based on their intuition and experience. And automated, which relies on hand-authored predefined rules which may not generalize to all individuals. There are a handful of studies that implement PCG approaches for adaptive rehabilitation. They basically adapt the difficulty of the level based on users' performance. This work applied constructive PCG approaches that use a set of predefined content, assuming that the subjects are known ahead of time. Instead, our work assumes that the subjects are unknown and show different behavior. Therefore, content needs to be generated and adapted dynamically based on each subject's need. Experience-driven procedural content generation, EDPCG, provides a framework for systematically creating and modifying the content to optimize the user's experience. We argue that EDPCG can be used for adaptive virtual reality exposure therapy. There are several approaches for obtaining user experience in the EDPCG framework: subjective, objective, and gameplay-based. In the subjective approach, the user gives feedback about their experience, which might be subjectively biased or intrusive during the session. The gameplay-based approach assumes that the user's interaction and performance in the game represents their cognitive state. However, these parameters are a low-resolution model of the player's experience and are not ideal for exposure therapy. The objective approach attempts to indirectly model the user's emotional states through their physiological response. Although this approach requires wearable sensors, it potentially fits in the exposure therapy context. This is our proposed system framework. In this framework, subjects interact with a virtual reality environment. Our framework collects physiological measures while the subject is interacting with the system to estimate the stress level. The procedural content generator uses the estimated stress level to change the VR environment in real time in order to induce the desired stress level as quickly as possible. Then the subject interacts with the new virtual environment, and this is how this loop is closed. We have applied our proposed framework on arachnophobia as a case study. The virtual reality environment includes spiders with different attributes, including appearance and movement. We have found these attributes in the related literature. We have also generated 100 virtual subjects that fear from spiders differently to interact with our system. We have used reinforcement learning as our procedural content generator. It gets the stress level as input and decides how to change the virtual reality environment accordingly. We showed that EDPCG outperforms the baseline methods in terms of finding the desired spider as soon as possible. For the stress estimator component, we have used a public domain dataset named VESAT. In this dataset, 15 subjects exposed to stress stimulus followed by calm periods, and they have collected their physiological response. The physiological measures include temperature, respiration rate, skin conductance, and ECG. Then we have applied different machine learning algorithms to find out if a person has stress or not. As you can see, random forest has the best accuracy on the test dataset with 89% accuracy. This image shows an example of running our framework for a subject. The desired stress level is set to 7 here. This image shows that the RL agent changes the spider with the attributes represented in the left side, which is a small spider far away from the subject, without hair, brown color, and without the movement. To the attributes represented in the right side, which is a large spider very close to the subject, with hair, black color, too much movement, and human-like locomotion. This is our future plan. First, we plan to develop a system that estimates the subject's stress level based on physiological responses. We plan to train 2 machine learning algorithms, a random forest and an LSTM, to classify the subject's physiological response to baseline and stress states. Second, we intend to find an appropriate set of parameters for specific exposure therapy goals, using psychological literature and asking experts in the related fields. For example, in fear of public speaking disorder, the size of audience is an exposure parameter, but the environment brightness is not relevant. Next, we use transfer learning to employ the information from previous subject to a new subject. The idea is that because all the subjects suffer from the same disorder, we expect that they may show similar behavior to some extent. Finally, we intend to conduct a human subject study. The study will start with a simple experiment that presents relaxing and stressful situations to observe how effective our VR environment is in terms of inducing stress in the subjects. We expect to observe significantly different physiological response in these 2 situations. Then we compare our proposed framework with non-adaptive VR environment in an arachnophobia test case using non-phobic individuals. We will compare our framework with other approaches in terms of different metrics that reflect exposure therapy effectiveness, such as quickly reaching and maintaining the desired stress level. The purpose of this study is to present an EDPCG-based framework for exposure therapy, wherein it collects user experience based on objective measures. Therefore, accurately estimating the user's experience is critical, which affects the framework performance directly. An initial challenge is to find the optimal number and types of sensors to measure physiological response, which is a trade-off between intrusiveness, cost, and accuracy. Another challenge is to evaluate a stress level as a multi-classification problem instead of a binary classification. Studying the trade-off between the granularity of the multi-classification problem and the model's accuracy is also important. Finally, we are required to evaluate our framework on real subjects. Thank you very much. Feel free to send me an email if you have any questions.